Hello everyone, welcome back to my YouTube channel. I am Dr. Faizi. Today in this video I am going to explain about reactions of aldehydes and ketones. I request you please go through my previous video and see the nomenclatures and synthesis of aldehyde and ketones. So let us start the oxidations of aldehyde. You know the oxidations, now you know the reductions. So how oxidations of aldehyde gives carboxylic acid? Aldehyde can be oxidized to carboxylic acid. I told you about the oxidation of aldehyde when I discussed the oxidation of primary alcohols to form aldehyde, which under certain conditions are further oxidized to carboxylic acid, and this oxygen come from oxidizing agent. Look at here, this oxygen, and this is your carboxylic acid. A specific example of oxidation of an aldehyde is a reaction that my students do in a laboratory activity. They use the permanganate to oxidize benzaldehyde. This is benzaldehyde. You just oxidize it, then you will get the benzoic acid. So write it down, the reactions. Reactions of aldehyde and ketones, reductions of aldehyde and ketones. What is the reductions? It is opposite of oxidations. Reductions of an aldehyde or ketones produces an alcohol. This is reverse of the oxidations of alcohol reactions. The general form of equations for the reductions of an aldehyde ketones, look at here, this is aldehyde or ketones give the an alcohol. As was, you see this and this is for oxidations and this sign for reductions. Often written above arrow in chemical equations to indicate the reactant is being reduced. So reductions of aldehyde and ketone. Reductions of aldehyde or ketone involve the formations of a bond to carbonyl carbon by a hydride ions H- radical. The accompanied by the bonding of H+ ion to the carbonyl oxygen atom and the conversion of the carbon oxygen double bond into a single bond. Look at this, you can see RCO or aldehyde or ketones. You have this hydride ion from a reducing agent. This hydride ion from reducing agent. Hydride ion from reducing agent. Look, and H+ ion from water or H. So forming this an alcohol. So aldehyde can are reduced to primary alcohol and ketones are reduced to secondary alcohols. Remember it. In biological system, the hydride ion used in the reductions of aldehydes or ketone is supplied by nicotinamide adenine dinucleotide hydride NADH or other organic hydride ion source. For example, the final reactions in the yeast alcohol fermentations process is the reactions of ethanol with NADH and H+ to form ethanol and NAD+. Ethanol, NADH, H, this hydrogen is coming from NADH and H+ from acid, forming ethanol. Enzyme, in the presence of enzyme, this reaction occurs. Now, the reductions of aldehyde and ketone in the laboratory, hydride ion from aluminum hydride or borohydride are used as reducing agent. Hydrogen gas H2 is used as a reducing agent in laboratory and industrial applications. Reduction that use hydrogen gas is called hydrogenation reaction. They occurs at high temperature and in the presence of metal catalyst, often platinum metal surfaces. Hydrogenation reaction do not use the mechanism of additions of hydride and H+ ion that I previously described. A discussion of the mechanism for catalytic hydrogenation is beyond the scope of our lecture. However, you can predict the product for the reductions hydrogenation of aldehyde or ketone by forms the carbon oxygen double bond. So look at here, this is aldehyde or ketone forming this. What happened? RCO hydrogens forming this, and you have hydrogens in the alcohol. So if you have propanone H2 forming 2-propanol ketone to aldehyde. To understand these reductions, just take copy and pen, write it down and write it down the products. The reaction of aldehyde or ketone with alcohol, hemiacetal or acetal production. A hemiacetal is a molecule that contains both an OR group and OH group that are bonded to the same carbon. OR, OH groups, general form of hemiacetal. An acetal is a molecule that contains two OH groups where both OR groups are bonded to the same carbon. So hemiacetal and acetal. An aldehyde or ketones will react with an alcohol from hemiacetal, or OR from the alcohol form a bond to the carbonyl carbon of aldehyde or ketone. H from the alcohol bonds to the carbonyl oxygens, and the carbonyl groups double bond is changed to a single bonds. A hemiacetal that is formed can react with the second alcohol molecules to form an acetal and water molecules. The structure of acetal that is produced is drawn by exchanging the R groups of the alcohol and H from the hemiacetals, hydroxyl groups, you see here. So this H and this OR, this OR, this is hemiacetal, this is acetal. Now you have worked to draw the structure of hemiacetal and then acetal that formed by the reactions of ethanol and ethanol. So draw it. This is hemiacetal, this is acetal. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching. Don't forget to share it with your friends.